You dig? I'm going to draw a quick unit circle, okay? Going to draw my 4 quadrantal points. Okie dokie. This is just to see if everybody kind of gets what's going on. You know what I'm saying? Where does 0 begin? Well, 0 begins here, right? You guys agree with that? Okay. So what I want to do is I want to fill out this chart. Okay. And you guys all agree that sine goes with which of those values as I go around, the x's or the y's? Or the y values. And that cosine goes with the x's. All right, so here's what I want to do. Great, I'm going to make your 5 a 6, okay? I'm going to make your 5 a 6. So I want to label all of these points as I go around this, okay? So I want to know, Trinity, what is sine of 0? Well, sine of 0 brings me to the beginning, right? And what is the sine of 0? Do I want the x or the y? The y. So what is the sine of 0? The 0, right? You said 1.
Yeah.
Why? Okay. Do you agree it's 0 now? Good. So sine of 0 is 0. Everybody okay with that? Let's put that on our chart. All right. I didn't make your 5 a 6, so we gotta fix that. Okay. So now I want to go 90 degrees, which means I want to rotate this way, right? I want to rotate from here to here. So what is sine of 90 degrees? X or the y? The y. So which one am I going to choose? The 1? All right, so Trey, now I'm going to go to 180. So now I'm going to go here, right? So what's this value going to give me?
What?
I'm here at 180 now, right? So which is the sine of 180? 0, good. All right, and now I'm going to go to 270, so now I'm down here, right? What's that one going to give me? -1, good. And then I'm going to go 360, which means I'm going to go all the way around to where I began. And what was the y value where I began? 0. Now, Trini, do you agree that I could have went, instead of in a positive rotation, I could have went a negative rotation? So I could have went -90. So if I went this way, I'd still start at 0, but -90 would give me, how's he? -1. And then from -1, I'd go to 0, and then I go to 1, and then I go back to 0. All right. Jaden, if you were going to like paraphrase what we just did, how would you paraphrase it? I started here and I chose the y values as I went around the circle, right? So if I want to do the same exercise now for cosine, I'm going to choose the x-axis, x values as I go around the circle, right? So I'm either going to go this direction and choose x values, or I'm going to go this direction and choose x values. But I'm always going to start at 0, right? So Jane, what is cosine of 0? Okay, so I'm going to go at 1, right? So now I'm going to go to 90 degrees, which means I'm going to go this direction, right? So what's my next value? 1 goes to, 0 goes to, -1 goes to, 0 goes back to 1. Or I could go the other way, right? So 1 goes to, 0 goes to, -1 goes to, 0 goes to 1. All right. Guys, it seems like a fruitless exercise. Until we put these points on a graph now, okay? So what I'm going to do is I'm going to take these points in yellow, all right? And do we all agree that negative 2 pi is right here on my graph? All right, so I'm going to graph my sine curve. All right, so I'm going to graph negative 2 pi 0. Negative 2 pi 0 puts me right here. Okay. What's the next point I'm going to graph? Well, at negative 3 pi over 2, I'm going to go to what? I'm going to go to 1. So at negative 3 pi over 2, I'm going to go to 1. At negative pi, which is here, I'm going to go to what? Back to 0. All right. At negative pi over 2, I'm going to go to negative 1. And then I'm going to go to 0. And then I'm going to go to 1, and then. All right. So I get all these points, and they seem kind of like, I don't know, strategically placed. Does it look like there's a pattern here? Yeah, right? It looks like if I played connect the dots, that I would get something that looks like that, right? And then check it out. Don't you guys agree that if I connect these dots, don't I get another pattern that looks like this, right? See how that, I'm dotting this in, I'll fill it in, but do you see how the dotted line matches the solid line? Yeah. This is going to be called, guys, a cycle, right? This is one cycle. See how it goes up, goes back, goes down, goes back, right? That's one cycle. We'll talk more about that word in a minute, okay? Guys, this is your sine curve. Cool? Right? Now I'm going to do the exact same thing with my cosine points, okay? Now, if you look at it, the values look really, really similar to the one that we just did, don't they? Yeah. Except where am I starting here? I'm starting at 1 to 0 to negative 1. Okay, so I'm going to start 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1 to 0 to 1. And if you play connect the dots, your curve looks like that. And that's cosine. Hezzy, those look real similar, don't they? Yeah, look real similar. We'll talk about how to distinguish between the two in a few minutes. Okay, but getting those is nothing more than doing what? Taking points off the unit circle at the quadrantal angles. Fair to say? All right, not a real difficult process, is it? Okay. Now, guys, really quickly, check this out. Jaden, I asked you to give me cosine of 0, right? And then I asked you for cosine of 90, cosine of 180, cosine of 270, cosine of 360, right? Could I have kept going and asking you for more? Could I have said, give me cosine of 450 and cosine of 530 and cosine of 620? I could just keep asking him to do that, couldn't I? Because I can keep what? Going around and around and around my circle, right? So is there any limit to the number of times I can go around my circle? No. So the domain is all real numbers. I can ask him to go around the circle as many times as I want, can't I? So did we create a complete graph, or is there more graphs that I could sketch? I could keep going, right? And this pattern would what? Just keep going. Yeah, it would just keep going. It would just keep going forever and ever and ever and ever, right? I did the slinky in here, right? I didn't do the slinky in here? Oh, okay. Let me do the slinky. So, if I took my slinky, I need somebody to help me for a second. Okay? So, if I took my slinky. Yeah, perfect. You know what? You're kind of house. Let's get out. Stand on this side and hold this slinky right here. Hold it right there. Okay, that's good. So what I'm going to do, guys, is if I was to just take my hand and just start going back and forth, right? As long as she keeps it on there, do we see how this pattern just keeps going back and forth and back and forth and back and forth, right? Now, the shorter that I move my hand, the kind of smaller those little waves are. The faster I move it, the faster those waves are in between. Now, this actually works better if we do it on a, here, hold it down there for 1 second. You guys can barely see it. We're going to put it on the ground for a second. But if I start going back and forth, if you can see it, that's cool. If not, stand up. But if I go back, you're just going to stand still. You're just going to stand still. Do you see how we create little sine waves in here, right? These duplicating things. If I go a little further, right, they get a little bigger. If I go a little faster, I get more of them. See how I have more of them in there now? If I go a little slower, I get less of them. Okay? I'm going to be using a word in a few minutes with you guys. That word's going to be frequency. Where have we heard the word frequency before? Radio. Radio. You know why? Because guess what radio waves are? Sine curves. And guess what distinguishes one sine curve from the next? How quickly that moves, right? If I move it really, really quickly, you're going to see more and more curves in a shorter amount of space. If I go really, really slowly, you're going to see less curves in an amount of space. So how powerful that signal is, how quickly those curves move, is the difference between listening to 97.9 and 106.7. Okay? So that's exactly where it comes from. It comes from pulsating of energy that goes out that you can tune into, right? Kind of cool, right? But that is exactly what's going on, okay? Now notice in this particular picture, guys, when I talk about range, range is nothing more than lowest to highest point, right? Both of these graphs have the same low point. They both have a low point at -1, right? And then they also have high points. What's the high point of both graphs? +1. Now, I just gave you guys a new word. We got to do part D. We'll do part D in a minute. Period. Period's not a word that I used yet, okay? I'm going to use frequency and period together, okay? Period. Remember we talked about the fact that we have cycles that occur, right? Patterns. You guys all agreed that for sine, that was one pattern, right? How's you watch this? If I grab this yellow and I slide it over here, do you see how the blue one fits right on it now, right? Okay. How much space did it require me to complete one cycle? How much space did it require me to complete one? Oh, don't do that, Ricardo. There you go. How much space did it require me to complete one cycle? Horizontal space. You said how many units? Okay, so you're actually counting the boxes? Okay, good. Now what I want you to do is I want you to use the labels. So you said it took 8. You said 8 boxes. So you're saying one cycle starts here and ends here? No, one cycle starts here and ends at. Oh, hang on a minute. Okay, so hang on a minute. Hang on a minute. So we got to make sure we understand that word cycle. This right here is one cycle. So this is one cycle here. This is a second cycle over here now, right? So how much space, how much horizontal space did it require me to complete one cycle? So I heard a half. I heard 4. Okay, now let's use the units on here. It starts at 0 and it ends at 2 pi. Or it starts at -2 pi and it ends at 0. In either case, how much space was that? 2 pi space, right? Now, couldn't I have done the exact same thing on my cosine curve? Do you agree that my cosine curve looks like that. Do you agree that that's one cycle because I have a duplication of it right here? How much horizontal space did both of those require me to use? 2 pi, right? So when I talk about the period is 2 pi, and that's because it takes 2 pi space to sketch one cycle of sine of x or cosine of x. Now, what do you guys think I could do with a sine curve? Well, I just said a minute ago, I said if I start to, what happens? Well, those curves start to either get pressed together or stretched apart, right? We'll talk more about that over the coming days. But for right now, what I want to do is I don't want to go this way. I want to go this way. Now, what does that require me to do? Well, essentially, it requires the following. So I'm going to give you guys an example of how this is going to work now. Ready? Your car radio is looking for a particular amount of inputs to come in every second, let's say, right? That's what it's looking for when it tunes into 97.9. But what happens as I drive further and further away from Rochester? Okay, hang on a minute. It does? Does the channel change? No, the signal gets weaker. Why? Because I'm driving further and further away, right? And so those sine curves that are being sent out eventually do what? They run into houses, they run into the road, and eventually the earth is curved, right? So what happens when they send out these signals, they eventually get sent out in a way that they can't reach my car radio anymore, right? So what do companies do so that when you drive a little further away, they work a little bit better? They turn up the power, right? They send out more powerful radio waves. So what do you think that does to these curves? It stretches them this way, right? It makes them more powerful by increasing, it's going to be a new word, ready? The amplitude. The amplitude is how tall these curves are, okay? Now, I'm going to use a I sort of lied in the way that I said that, okay? An amplitude has a high point and a low point, okay? What is the high point here? 1. What is the low point here? -1. So the amplitude of this is 1, okay? Now, I used a bad word, Jaden, because I said the amplitude is like the height. It's well, sort of. Don't use that phrase yet. Keep that in mind because we're going to move it around in a minute. But the height of this curve, if I asked you how tall is this curve, what would you say? What's the low point? What's the high point? So how tall is the curve? 2 units tall, right? So isn't the amplitude half of the height? That makes sense? Okay, it's kind of like half of the height, okay? So we've actually put a lot together right there, okay? What we're going to do is this. You have a company that is broadcasting on a cosine of x curve, okay? They're not getting enough listenership, so they want to boost the signal 3 times. They want to make the signal 3 times larger. So first of all, this 3 is the amplitude, okay? Now, which curve is this based on our conversation from the last page? Is this a cosine curve or is this a sine curve? This is a cosine curve. Now, okay, here's what I want to do to this cosine curve. I want to make it 3 times more powerful, right? So check this out. Sadie, do you agree that this point right here has a y value of 1? Okay, not a trick question. If I want to make the signal 3 times more powerful, where's it going to move? Up. Is it going to move up 3? So I heard move it up 3. So if I move it up 3, it's going to go 1, 2, it's going to go here. Don't put that there yet. I'm going to move it up 3. Now listen to the word I said. I'm going to make it 3 times more powerful. If I shift it up 3, where is this point now? It's now at 4. Did I want it to be at 4? No, 3 times more powerful would move 1 to 3. So I don't move it up 3, I multiplied the 1 by 3. 1 times 3. Sadie, what's the y value right here? Where's my cursor? No, right here. 0. What does that mean? That means I'm not sending out any signal at all, right? If I make it 3 times more powerful, how much signal am I sending out? 0. This is a -1. 3 times more powerful makes it -3. This is 0 and 3. So if you look at this curve, guys, what do you notice? It looks very much the same. It's just been what? Stretched out vertically, right? More powerful signal, right? More powerful signal. Hey, check it out though. Ready? Same amount of space, right? Same amount of space required to complete one period though, right? So same channel is going to pick it up, isn't it? Yeah. So setting up the power doesn't mean I have to change the channel. Make sense? Okay. And then we're going to have another cycle of it. So boom, boom, boom. Is that okay? All right. We're going to do this one now. Now this is going to seem kind of weird, but let's actually use what we did on that last problem to help us. I want to multiply cosine by -4. Trinity, see my cursor? What y value is my cursor on? 1. What's 1 times -4? -4. So this point moved from 1 down to -4. You'll see what happens in a second. What's my y value right here? What's 0 times -4? Okay. What's my y value right here? -1, right? What's -1 times -4? +4. This is 0. This is 1. 1 times -4 is -4. And here's my first cycle. Can somebody give me a word? Reflect. Yeah. Yep. So a negative sign in front, right, did what to my blue curve? It reflected it in comparison to the black curve that we originally started with, right? Yeah. So this was a reflection and a stretch, right? Both happened. That reflected and stretched. All right, and that is -4 cosine of x. Really important question, T. Really important question. This green cosine curve, what's the amplitude? 3. What's the height of the curve? 1, 2, 3, 4, 5, 6. The green curve has a height of 6, right? So remember, the amplitude is always half the height, right? And that's what this says right here. The amplitude is always the what? Take the max, subtract the min, divide by 2. Make sense for an amplitude then? What's the amplitude of this one? Be careful, be careful, be careful. What is the amplitude of the blue curve? 4. The amplitude is 4. Well, Mr. Picardo, what about the negative? The negative just means it was what? Reflected. It didn't change the amplitude, did it? Everybody okay with the difference between those two? Okay. This 3/2, we're not going to do this example. 3/2 just means what? Multiply it by 1.5. That's all it means, right? So we could use fractions. Okay, that's not a big deal. I just don't want to confuse you with too many things in one area. All right, here. Which curve is this? That's the sine curve. Very good. All right, we're only going to graph this one and this one. Okay. So what do I want to do to get my red curve? I want to take all these points on here and do what to them? Multiply them by 2. So what's going to happen to this first point? What is the y value of this point? 0. What's 0 times 2? Okay. What's the y value of this point? 1. 1 times 2. And then 0. -1 times 2. And then 0. And so again, what do we notice? It is the exact same curve except stretched. What can you tell me about, oh boy, high five and kind of like a math geek hug goes out to anybody that can give me a statement regarding the following. Changing the amplitude of a trig function does not what? Changing the amplitude of a trig function does not change. Go ahead, you're right there. You're right there. Does not change. Okay, the x value stayed the same. The x value stayed the same, particularly for which ones? Which points are really kind of important that stay the same? The zeros, right? The roots of the black and the roots of the red are exactly in the same spot, aren't they? So changing the amplitude does not change the roots. So when I graph my new blue one, I know that what? I know that this point, this point, this point, this point, and this point stayed the same, didn't they? Now, what do I notice about this curve? What am I going to do? I'm going to change the amplitude to be 3, and I'm going to reflect it. Which means, ready, check it out. This is the way I think about it. If I wanted to trace my black curve, I would start here. I would go up, down, up, down, up. So now I'm going to do the opposite. Instead of going up, down, I'm going to go down, up. So this is going to go down to -3, back to here, up to -3, and back to the root. So do you notice how this is a reflection of the black curve that has been stretched 3 units? And that is my last cycle of it. How are we doing? Seemingly okay? Now, I want to show you guys one more thing. And we're going to look specifically at these examples for a minute. We got this incredible, amazing, fantastic tool that we can use. So all I want to do, right? So here, you grab your calculator, you say, okay, cool, Picardo. Sine of x, and you get this, right? And you get this. But I want you to look at our sine of x on the previous page. Sine of x was in blue, right? Does our paper look exactly the same? Well, it looks pretty much the same, doesn't it? Okay, here's the problem I got with this, because I do have a problem with this. I got a couple of problems with it. Here's one of them. Look at what this says right here. What does that say? What does that say? 10. What does my paper say? 2 pi and negative 2 pi. So I want my graph to match that. So I'm going to go negative 2 pi to positive 2 pi. By the way, what's the highest point on this curve? 1, 2, 3, 4. The lowest point, negative 4. Watch this. Boom. Okay, what do you guys think? Does it look pretty good? Yeah. Looks really good, doesn't it? Okay. What mode are we in? We're in radian mode. Now I told you guys not to worry about modes, right? Okay. What do you notice about what I didn't do right here? Sine of x what? What usually goes in here? The degree, right? What did I not put on here? All right, so watch what happens were I to put a degree symbol on here. Oh, doesn't look the same anymore, does it? Why doesn't it look the same anymore? Because if I change the conversation to go in degrees, then what does negative 2 pi become? 2 pi, negative 360. Because what's pi equal to? 180. What does 2 pi become? 360. So if I want to start getting into degrees, then I got to make sure that I'm in degrees. You like that, Hazy? Cool, right? Now notice one more thing, and this is going to be the greatest cheat of all. The greatest cheat of all is this whole chart up here would be really nice to be able to get without doing any work, right? What do you notice about the values that I was really interested in? Weren't they the quadrantal angles, the ones that are multiples of 90, starting at 0? Watch this. Wouldn't it be nice to go to my table? Well, what's not nice about my table? My table is not jumping in increments of 90. It's jumping by increments of 1. You guys know you can change that? Watch this. So all I did was hit Control T, right? Do you see how like there's a little black outline if I click on either side? See the little black outline right here? If I click over here, it's over here now. Make sure that this is outlined. If you hit menu, you can now go into the table settings. I want to start my table at, so where did this table start? At negative 360, right? So if I start my table at negative 360 and my table steps by how much? Step means how much does it take to go from one to the next? I want to step by how much? 90. What's it going to do now? It's going to literally give me that chart. Now here's one of the problems with the calculator, guys, and you got to be aware of this. Do you see these right here? 1e to the negative 13, right? What is that the same as? What's 1e to the negative 13? Negative 13 scientific notation, right? That means move by decimal which way if it's negative? Left or right? Left. So if I add 13 zeros, what does this say? It says 0.00000000000001. What is that number the same as? 0. So this really means 0. But what's really cool about this, guys, is it gives you our chart now, doesn't it? Okay. If we look at the ones that we just did, And we'll do more with the calculator tomorrow. But Trinity, I want to make sure that I did my blue graph right. So I want to make sure I graphed -3 sine of x right. So I'm going to go -3 I'm going to go sine of x. Okay, so now we have to have a conversation. Ready? Do you want to do this problem in terms of degrees or radians? I don't care, you choose. Radians, good. You guys said radians? I'll do radians. Boom, okay. Now what do I need to do? I need to change my window, right? What should be my minimum value if I'm in radians based on the picture? -2 pi. Okay, what should my maximum be? 2 pi. Okay, good. I think this is what my picture should look like for -3 sine of x. Does it match what we did? Now, if I want to make sure, what can I always do? I can go to my control table. I can go into my table settings. I want to start at -2 pi. What should my step be now? Because I'm talking about radians now, right? So I want to jump by 90 degrees. What's 90 degrees in radians? Pi, half a pi, right? Or pi divided by 2. And check it out. There's a chart of values that we can plot, isn't it? Isn't that sweet? So I can literally just plot these values and I'm ready to rock and roll, okay? Again, why did I have to jump by pi over 2? Because I was in radian mode. If I want to change the whole conversation because you don't like dealing with radians, then what are we going to do? On this, we're going to add a degree symbol. And then I'm going to change my window to go from -360 to +360. And now I can see it in degrees. Cool? Yeah. All right. I'm going to stop right there, guys. Tomorrow we're going to shift these things up and down. You should be keeping up with the homework, okay? You should be between 8.4 and 8.5 right now, okay? You should be in that range